Hey everyone, I'm going to head and take a look at homework 5-7 to help some of us out. Again, if you missed class or if you just need some help with it. And as always, go ahead, pause the video, rewind, and do whatever you need to do. This is the base homework, so I might have removed some questions. That might have happened for your class. But I'm going to head and go with what all the problems that you could have on your homework. So we're going to start with finding all the zeros of the quadratic function of x squared minus 12x plus 36. Generally, there's two ways we could do this one, factoring or by graphing. So again, zeros are going to be our x-intercepts. So if you graph them, that's what they want. By the fact that they don't want me to have decimals, typically tells me I'm going to have whole numbers, which means that this should factor out nicely. So this might be a good review for you. So if I do my X box method, where I have A times C in the top and B in the bottom, we multiply the two side numbers and we add the two side numbers depending on what we're looking for. 1 times 36 is 36, B is 12. So I need two numbers that add up to 12 but multiply to 36. So I'm going to do 6 and 6. So if I go ahead and do my X box, I would have x squared, and I'm going to separate negative 12x. Oh, so this is a negative 12. So these are minus. And now I have negative 6x, negative 6x, positive 36. So I pull out my GCF of the first row, first column, so I get x and x. X times negative 6 gets me negative 6x. Negative 6 times negative 6 gets me positive 36x. So I have x minus 6 times x minus 6, and you will notice these are the same thing. So what I'm going to head and do is set one of them equal to 0. X minus 6 equals 0. Solve for x by adding 6. And I get x equals 6. So I have 1 0. I'm going to have to hide this so I can submit my answer. And all I'm going to do is do 6 and hit check. And it does work. If you were to graph this, if I were to graph this and we said at 0, 6, it will look something like that, not necessarily exactly that shape, but something like that. If I kept going, it would cross at 36, just kind of how it looks like. I do know that part. Other than that, I don't really know. You can go ahead and graph if you really want to see it, but this was how you could do it without a calculator. Again, if you graph this, I'm going to try. We're going to see if I can. Maybe Desmos will work for me today. My guess it probably won't. Odds are it's not going to do what I want. I can hope though, I guess. Yeah, it's not going to do it for me. I want it to so bad. I really want this to work. Let's see if I do. Yep. Yeah, it's not going to work for me. It just won't. It makes me really sad. But I can't get it to graph for my life. So I can't even show you one here. But you can graph it and you would see it crosses it only touches the x-axis at 6. So this one says write a quadratic function whose zeros are -2 and -9. I'm going to point out here, and I want to stress this. It never says what kind of function to write. It never says whether it wants ax squared plus bx plus c. It doesn't say it wants a times x minus h squared plus k, or if it says x minus p times x minus q. Those are generally our three forms of a quadratic. It doesn't say what format it wants. So since it doesn't say, I'm going to be lazy and use a factored form, because it already tells me what my P and Q are. So remember, P and Q are going to be my zeros. So for this, x minus -2, x minus -9. I'm going to clean it up though, because I'm just going to have x plus 2 times x plus 9. That's a quadratic equation, and that's what I'm going to go with. So parentheses, I said x plus 2, close parentheses, open parentheses, x plus 9. Make sure you close those parentheses. Never says you have to do it that way. If I look at, I don't know if they've updated it, but in the past they tried to force you to do a certain way. When you looked at the example, I'm going to see if it does it still. So they start out like this. And you can leave it like that so it works. In previous years, they had it where they kind of forced you to write it in standard form. That's no longer the case, which is great. So this one says, find a polynomial of degree 4 that has the following zeros: -4, multiplicity of 2, 0, and 1. So this multiplicity of 2 means it hits -4 twice. And the hint here says degree 4 means I have 4 sets of parentheses. So I have x minus 0, x minus 1, and it's saying I have x minus -4 twice. That is what it's saying when it says multiplicity of 2. It's how many times it hits that degree at that 0. So x minus 0 is just x. So I'm going to write it without parentheses. And I have x minus 1. X minus -4 would be x plus 4. And if it will let you, and it looks like it will because we have that exponent, I have x plus 4 twice. If you can write it this way, but what I would probably go ahead and do this right here is squaring. So I would rewrite it like this. And I know it's going to allow me to do that because it has the option for an exponent. So I have x parentheses, x minus 1, close parentheses, open, x plus 4, close parentheses, exponent of 2, and hit check. And there we go. I'm going to hit try another and see if it hits that multiplicity again. No, so this one doesn't give me the multiplicity. I just wanted to see if it would accept the x minus x plus 4 twice. So this would be x. Actually, because I have this 0, we already know it starts with an x. And I'm going to start with open parentheses. X minus 9, close parentheses, open parentheses, x minus 8, open close, x minus 1, open close, and then I'm going to have for my last one a plus, so x plus 5. So that's another one you could do if you don't have a multiplicity. And I know I need 5 sets because it says degree 5. All right, so using Descartes' rule of signs. Use Descartes to determine the possible number positive and possible number negative. So when we do positive, you leave everything as is. If you are missing one, you need to put a plus 0x in. So we have negative. We have -2x to the 4th minus 7x cubed minus 8x squared minus 5x plus 2. That makes it really easy, actually. And so we're going to take a look at the change of signs. It does not change here because it's negative, negative. Does not change, negative, negative. Does not change, negative, negative. It does change from negative to positive here. So I have the possibility of one real zero that is positive. And you do it based on the number of sign changes. So there is a possibility of 1. And it actually tells me what my other possibilities are. But we're going to go ahead. For the possible number of negative real zeros, you change all the negative exponent, all the odd exponent signs. So I keep negative 2x to the 4th, but I'm going to change 7x cubed. I leave 8x squared alone. I change 5x, but I leave 2 alone because it technically 0 is where they count as even. And so again, I check for sign changes. Negative to positive. So yes, again, my only sign change happened here. Positive to negative. So yes. Negative to positive. So that was a yes. Positive to positive was no change. So the possible number of negative zeros is going to be 3. But I could also actually have 1. And so you do the rule of subtracting by 2 every single time. And so I'm going to actually hide this. Hide. So here I would write, I had only 1 sign change, so I have to have 1 positive 0. Here I had 3, but I could also have 1. And if we take a look at an example here where it's going to pull up Descartes' rule of signs, which is always something very useful to have. It tells you the number of real zeros is equal to the number of sign changes or less than by that of an even number, so by 2's. So they show you the sign change, so I can have 2 or 0 because I can subtract 2 every single time. One thing that you should end up getting is if you have an even number, the total number of zeros should add up to an even number possibly. So I'm going to hit check and I should get 1 or 3 or 1. And this one is correct. So let's take a look at 5. So they want us to go ahead and multiply here. This is a really big box. It's not horrible to do, just a box method. So I'm going to draw a box. You'll see why I draw it so big, and I'm going to draw it like that. So I have x minus, and what I'm going to head and do is I'm going to head and distribute this minus sign to everything. So here we have negative 2 minus 3x, because if you distribute, or 3i, you distribute that negative sign. Negative 2 plus 3i is what we have here. All right, so x times x is x squared. X times negative 2 plus 3i is going to get me negative 2 plus 3i, and I'm going to leave it like this, and I'm going to hope, my whole hope here is that they're going to cancel out. Oh, actually, no. Let's go ahead and multiply them through. So I get negative 2x plus 3xi. X times negative 2. X minus 3xi. And something will cancel out there. And in here, I have another kind of box to go with. I'm going to do negative 2 times negative 2, which gets me positive 4. So I did those two. And then negative 2 times positive 3i gets me negative 6i. Negative 2 times negative 6i. Ooh, so this one's actually a plus 6i. Gets me negative 6i. I'm running out two color choices. Red and red. So negative 3i times positive 3i gets me negative 9i squared, which equals positive 9. So the reason I did this is things do start canceling out. Those cancel each other out. This 3xi, that 3xi cancels out. So I'm not going to worry about it. I get x squared. Negative 2x plus negative 2x is negative 4x. And I'm left with a plus 9, or 9 plus 4 is 13. So x squared minus 4x plus 13 is what I'm going to head and write in here. Out of it, and what did I say? Minus 4x. Minus, no, plus 13. And hit check. So there's that one. They're saying it is possible for you to have I in there. So if my I's, so for example, if either my I's did not cancel out here or here, generally they will here, you're going to have to write the answer with I in it. Find a polynomial of f of x of degree 3 with the real coefficients and the following zeros. Negative 4 and 2i. So our rule here is all i's come in pairs. So if I have 2i, I also have negative 2i. And that's just what the pattern is. Can't have positive I without negative I. They just come in pairs. So I do know this is going to be written as x minus negative 4 times x minus 2i times x minus negative 2i. So this becomes x plus 4 times x minus 2i times x plus 2i. And so knowing our special factoring techniques from 5-5 actually makes this a lot nicer to deal with. If you don't recall them, you can go ahead and do the long way. This here is a difference of two squares. It's a minus b times a plus b. So from this, I know I'm going to get x squared minus, actually plus 4. And it's a plus 4 because 2i times negative 2i equals negative 4i squared. But I squared is the same thing as negative 1. So negative 4 times negative 1 equals 4. So that's why it's a big plus 4 there. If you want, you can go ahead and do your box and see that things will cancel out, which I will go ahead and do. We get our x squared. We get negative 2xi, we get positive 2xi, so those cancel each other out. And again, we get negative 4i squared here, which will just equal positive 4. And from there, I would do another box. I'm going to put x plus 4, x squared plus 4. Yeah, so x cubed, 4x squared, 4x, and 16, which will get me x cubed plus 4x squared plus 4x plus 16. And I should have a highest exponent of 3. So we're going to do x cubed. And the other reason I knew I had to do this is because they actually use the word real coefficients, meaning they don't want I in your answer. Out of the exponent plus, I believe, 4x squared. Out of the exponent plus 4x plus 16. I'm going to hit check. B is right. So that is how you go ahead and do that last question. Again, go back and rewatch the video if needed, rewind, pause, do whatever you need. But that is 5-7. And so I will see you guys next time. Good luck.